Question 1. An 4 of 1 liter of normal saline is to be infused over 8 hours. What is the flow rate in ml/hr? A. 100 milliliters per hour. B. 125 milliliters per hour. C. 150 milliliters per hour. D. 80 milliliters per hour. Answer: B. 125 milliliters per hour. This question tests the ability to calculate an 4 flow rate, a fundamental skill in a hospital pharmacy setting. The keywords 1 liter and 8 hours require a conversion and a simple division to find the rate in ml/hr. First, convert 1 liter to 1000 milliliters, then divide the total volume by the total time. 1000 milliliters divided by 8 hours equals 125 milliliters per hour. Think of it like a road trip. If you travel 1000 miles in 8 hours, you divide the distance by time to find your speed. Always double-check that your units match the question. Here, converting liters to milliliters is the crucial first step. Question 2. A patient is prescribed Lantus 30 units subcutaneously every evening. How many ml will the patient inject per dose from a 100 Lantus vial? A. 3 milliliters. B. 1 milliliter. C. 0.3 milliliters. D. 0.03 milliliters. Answer: C. 0.3 milliliters. This question assesses the calculation of insulin volume based on its concentration. The key information is the dose of 30 units and the concentration U100, which means 100 units of insulin per 1 milliliter, ml, of solution. To find the volume for the dose, divide the prescribed units by the concentration. 30 units divided by 100 units/ml equals 0.3 milliliters. For insulin calculations, it is essential to recognize that U100 is the most common concentration and represents a standard ratio. Remember, for U100 insulin, you can find the volume in ml by simply moving the decimal point of the unit dose 2 places to the left. Question 3. A prescription is written for metformin 500 mg tablets, ITAB PBID. If the pharmacy dispenses 180 tablets, what is the day's supply? A. 30 days. B. 60 days. C. 90 days. D. 180 days. Answer: C. 90 days. This problem requires calculating the day's supply, which is critical for insurance billing and patient adherence. The key is interpreting the SIG code BID, which is Latin for bis in die, or twice a day. This means the patient takes 2 tablets daily. To find the day's supply, divide the total quantity dispensed, 180 tablets, by the number of tablets taken per day, 2, which equals 90 days. A simple way to approach this is to first figure out the daily consumption and then divide the total quantity by that daily number. Question 4. How many grams of a 10% hydrocortisone cream must be mixed with a 1% hydrocortisone cream to prepare 60 grams of a 2.5% hydrocortisone cream? A. 50 g. B. 10 g. C. 15 g. D. 45 g. Answer: B. 10 g. This question tests the alligation method, a technique used in compounding to calculate the amounts of 2 different strength products needed to create a third, intermediate strength. Using the alligation grid, place the higher concentration, 10, in the top left, the lower, 1, in the bottom left, and the desired, 2.5, in the center. Subtract diagonally. 10 minus 2.5 is 7.5 parts of the 1% cream, and 2.5 minus 1 is 1.5 parts of the 10% cream, for a total of 9 parts. To find the amount of 10% cream, set up the proportion, 1.5 parts/9 total parts, equals, xg/60g total weight, which solves to 10G. Think of Alligation as a visual shortcut for solving complex mixture problems quickly and accurately. Question 5. How many milliliters of a 70% alcohol solution are needed to prepare 500 milliliters of a 40% alcohol solution? A. 200 milliliters. B. 286 milliliters. C. 350 milliliters. D. 700 milliliters. Answer: B. 286 milliliters. This problem requires using the dilution formula, C1V1 equals C2V2, to find the volume of a stock solution needed to make a weaker one. The keywords are the initial concentration, C1 equals 70%, final concentration, C2 equals 40%, and final volume, V2 equals 500 milliliters. Plugging these into the formula gives 70%, V1 equals 40%, 500 milliliters, which simplifies to 0.70 *V1 equals 200. Solving for V1 gives 285.7 milliliters, which rounds to 286 milliliters. This formula is essential for any task involving the dilution of stock solutions, from cleaning agents to intravenous medications. A good tip is to remember that your starting volume, V1, will always be less than your final volume, V2, when you are diluting. Question 6. A child weighing 44 pounds needs amoxicillin dosed at 30 mg per kilogram per day, divided into 2 daily doses. What is the amount in mg for a single dose? 1 kilogram equals 2.2 pounds. A. 600 milligrams. B. 150 milligrams. C. 300 milligrams. D. 1,320 milligrams. Answer: C. 300 milligrams. This is a pediatric weight-based dosing calculation, a critical safety check in pharmacy practice. The first step is to convert the child's weight from pounds, lbs, to kilograms, kg, by dividing by 2.2, which gives 20 kilograms. Next, calculate the total daily dose by multiplying the weight in kg by the prescribed mg/kg/day dose. 20 kilograms * 30 milligrams per kilogram equals 600 milligrams per day. Since the daily amount is divided into 2 daily doses, divide the total daily dose by 2 to find the amount for a single dose. 600 milligrams/2 is equal to 300 mg. Always follow the steps in order: convert weight, calculate the total daily dose, and then divide for the single dose. Question 7. What is the weight in grams of 120 milliliters of glycerin, which has a specific gravity of 1.25? A. 96 g. B. 120 g. C. 150 g. D. 125 g. Answer: C. 150 g. This question tests the concept of specific gravity, Sg, which is the ratio of a substance's density to the density of water. The key takeaway is that for water, 1 milliliter weighs 1 g, but for other liquids, this is not true. To find the weight of a liquid in grams, you multiply its volume in ml by its specific gravity. 120 milliliters * 1.25 is equal to 150 g. This calculation is important in compounding, where ingredients are often measured by volume but formulas require weight. A simple way to remember is, specific gravity tells you how much heavier or lighter a liquid is compared to the same volume of water. Question 8. A medication is available as a 150 milligrams per 5 milliliters oral suspension. How many ml are needed for a 90 milligrams dose? A. 2 milliliters. B. 3 milliliters. C. 4 milliliters. D. 5 milliliters. Answer: B. 3 milliliters. This question tests the use of ratio and proportion to calculate the correct volume for a prescribed dose. The known ratio is the drug's concentration, 150 mg per 5 milliliters. You need to find the unknown volume, xml, for the desired ratio of 90 mg. Set up the proportion, 150 mg/5 milliliters equals 90 mg/xml, then cross-multiply to get 150x equals 450, and solve for x by dividing 450 by 150, which equals 3 milliliters. This is one of the most common calculations performed daily in a pharmacy. Always start by setting up your known ratio on one side and the desired dose with the unknown on the other. Question 9. A solution contains 20 grams of dextrose in 250 milliliters of sterile water. What is the percentage strength, percent with V? A. 4%. B. 8%. C. 12.5%. D. 20%. Answer, B. 8%. This question assesses your ability to calculate percentage strength, specifically weight in volume, percent with V. The formula 4% with V is the grams of solute divided by the milliliters of solution, multiplied by 100. In this case, you divide 20 grams of dextrose by 250 milliliters of solution, which equals 0.08, and then multiply by 100 to express it as a percentage, resulting in 8%. This calculation is fundamental for verifying forward mixtures and preparing compounded solutions. Just remember the formula, grams/ml, *100 equals percent with V. Question 10. How many micrograms mcg are in 0.05 milligrams, mg? A. 5 micrograms. B. 50 micrograms. C. 500 micrograms. D. 0.00005 micrograms. Answer, B. 50 micrograms. This question tests your knowledge of basic metric conversions, a foundational skill for preventing medication errors. The key conversion factor to know is that 1 milligram, mg, is equal to 1,000 micrograms mcg. To convert from milligrams to micrograms, you multiply by 1,000, therefore, 0.05 milligrams * 1,000 micrograms per milligram equals 50 micrograms. A helpful tip for converting from a larger unit, mg, to a smaller unit, mcg, is to remember you will end up with a bigger number, so you multiply. Question 11. An 4 order is for 1,000 milliliters of D5W to be infused over 10 hours using a drop set that delivers 15 gtt/ml. What is the flow rate in drops per minute, gtt/min? A. 15 gtt/min. B. 20 gtt/min. C. 25 gtt/min. D. 30 gtt/min. Answer, C. 25 gtt/min. This problem requires calculating a gravity-fed 4-drip rate in drops per minute, gtt/min. This multi-step calculation involves using the total volume, total time, and the drop factor of the tubing. First, find the rate in ml per minute, 1,000 milliliters/10 hours equals 100 milliliters per hour, then divide by 60 minutes/hr to get 1.67 milliliters per minute. Then, multiply this rate by the drop factor, 1.67 milliliters per minute * 15 gtt/ml equals 25 gtt/min. The formula to remember is volume in ml/time in minutes, * drop factor equals drip rate. Question 12. A pharmacy purchases a bottle of 100 tablets for $40. If the pharmacy applies a 30% markup, what is the selling price for the entire bottle? A. $12. B. $28. C. $52. D. $55. Answer, C. $52. This question covers basic pharmacy business math, specifically calculating a selling price based on cost and markup. The keyword markup means you need to add a percentage of the cost to the original cost. First, calculate the markup amount by converting the percentage to a decimal and multiplying by the cost. $40 asterisk 0.30 equals $12. Then, add this markup amount to the original cost to find the selling price. $40 plus $12 equals $52. Never confuse markup with margin. Markup is added to the cost, while margin is part of the selling price. Question 13. A prescriber writes SS on a prescription. What does this Roman numeral abbreviation mean? A. 1. B. 2. C. 1/2. D. 5. Answer: C. 1/2. This question tests the interpretation of Roman numerals and abbreviations commonly used in prescriptions. The abbreviation SS is derived from the Latin semies, which means 1/2. Recognizing these abbreviations is essential for accurately interpreting prescribers' orders for quantities or dosages. For example, a prescription might read take 1 to 2 tablets, 1 to 2, or take tab SS, take 1/2 tablet. A handy trick is to remember that SS looks like it's been split in half, helping you associate it with the value of 1/2. Question 14. A medication must be stored in a refrigerator at 5 degrees Celsius. What is this temperature in degrees Fahrenheit? Formula: F equals C asterisk 1.8 plus 32. A. 25F. B. 41F. C. 37F. D. 50F. Answer: B. 41F. This question assesses the ability to convert temperatures between Celsius and Fahrenheit, which is important for ensuring proper medication storage. The formula is provided, so the task is to correctly substitute the given value. Plug 5 for C into the formula. F equals 5 by 1.8 plus 32, which simplifies to F equals 9 plus 32, resulting in 41 degrees Fahrenheit. Knowing this conversion is crucial as many medications require refrigeration, and temperature logs are often kept in one scale or the other. For a quick mental check, remember that 0C is 32F, so a small positive Celsius temperature will be a little above 32F. Question 15. A patient needs a dose of 250 mg of a drug that is available in a vial containing 1 g of powder. The instructions say to reconstitute with 4.8 ml of sterile water to yield a final concentration of 200 mg per milliliter. How many ml should be drawn up for the required dose? A. 1.25 milliliters. B. 1 milliliter. C. 1.5 milliliters. D. 2.5 milliliters. Answer: A. 1.25 milliliters. This question tests your ability to identify the relevant information in a multi-step dosage calculation. While details about the vial size, 1 g, and reconstitution volume for 0.8 milliliters are provided, the most important piece of information is the final concentration of 200 mg per milliliter. To find the volume for the 250 mg dose, you simply use the concentration, divide the desired dose by the concentration on hand, 250 mg / 200 mg per milliliter, which equals 1.25 milliliters. This type of question teaches you to filter out extraneous information and focus only on what is needed to solve the problem. Always look for the final concentration first. Question 16. A potassium chloride, KCl, oral solution contains 20 milliequivalent per 15 milliliters. How many ml are needed to provide a dose of 30 milliequivalent? A. 15 milliliters. B. 20 milliliters. C. 22.5 milliliters. D. 30 milliliters. Answer: C. 22.5 milliliters. This problem requires using ratio and proportion to calculate a dose for a medication measured in milliequivalents, milliequivalent. The known ratio is the concentration of the solution, 20 milliequivalent per 15 milliliters. You need to find the volume, X, that will provide the desired dose of 30 milliequivalent. Set up the proportion, 20 milliequivalent / 15 milliliters equals 30 milliequivalent / X ml, then cross-multiply to get 20x equals 450, and solve for x by dividing 450 by 20, which equals 22.5 milliliters. This calculation is common for electrolytes like potassium and sodium, where dosing is based on chemical activity, milliequivalent, rather than just weight. Question 17. To prepare a 2% W/W zinc oxide ointment, how many grams of zinc oxide powder are needed to make a total of 120 grams of ointment? A. 1.2 g. B. 2.4 g. C. 4.8 g. D. 60 g. Answer, B. 2.4 g. This question tests the understanding of percentage strength by weight, or percent W/W, weight in weight, used in compounding ointments and creams. A 2% W/W strength means that 2 grams of the active ingredient are present in every 100 grams of the final product. To find the amount of zinc oxide needed for 120 grams of ointment, you can set up a proportion, 2g/100g equals xg/120g, which solves to x equals 2.4 g. An easier way is to convert the percentage to a decimal, 2% equals 0.02, and multiply by the total weight, 0.02 by 120g equals 2.4 g. Question 18. A 2g vial of cefazolin powder is to be reconstituted. The label states that adding 9.6 milliliters of sterile water results in a final volume of 10 milliliters. What is the powder volume? A. 0.4 milliliters. B. 0.6 milliliters. C. 1 milliliter. D. 9.6 milliliters. Answer, A. 0.4 milliliters. This question assesses the concept of powder volume displacement, which is the volume that a lyophilized, freeze-dried, powder occupies once it is reconstituted. To find the powder volume, you subtract the volume of the diluent added from the final, total volume of the solution. In this case, the final volume is 10 milliliters and the volume of diluent added was 9.6 milliliters, so the calculation is 10 milliliters to 9.6 milliliters equals 0.4 milliliters. Understanding powder volume is important for accurate dosing, as failing to account for it can lead to a more diluted or concentrated final product than intended. Remember this simple formula: final volume, diluent volume equals powder volume. Question 19. A patient is instructed to take 2 teaspoons, TSP, of a medication. How many milliliters, ml, is this? A. 5 milliliters. B. 10 milliliters. C. 15 milliliters. D. 30 milliliters. Answer, B. 10 milliliters. This question tests the conversion between household units and metric units, a vital skill for counseling patients and ensuring accurate dosing. The key conversion factor to memorize is that 1 teaspoon, TSP, is equal to 5 milliliters, ml. Therefore, to find the volume for 2 teaspoons, you multiply by the conversion factor, 2 teaspoons * 5 milliliters per TSP equals 10 milliliters. Other common household conversions to know are 1 tablespoon equals 15 milliliters and 1 fluid ounce, Oz, equals 30 milliliters. Always be ready to convert household measures to metric units, as dosing devices like oral syringes are calibrated in ml. Question 20. A patient's body surface area, BSA, is 1.7 m². The prescribed dose is 50 mg/m². What is the total dose in mg? A. 29 mg. B. 50 mg. C. 85 mg. D. 100 mg. Answer: C. 85 mg. This question assesses your ability to perform a dose calculation based on a patient's body surface area, BSA, a method commonly used for chemotherapy and certain pediatric drugs. The calculation is straightforward once you identify the key values, the patient's BSA, 1.7 m², and the prescribed dose per square meter, 50 mg/m². To find the total dose, you simply multiply these two values, 1.7 m² * 50 mg/m² equals 85 mg. The units of m² cancel out, leaving you with the desired unit of mg. Think of it as a simple multiplication problem where you are given all the necessary information. Question 21. What is the ratio strength of a 0.5% with V solution? A. 150. B. 1:100. C. 1:200. D. 1:500. Answer: C. 1:200. This question tests your ability to convert a percentage strength into a ratio strength, a common task in pharmacy calculations. A percentage strength like 0.5% with V means 0.5 grams of solute per 100 milliliters of solution. To convert this to a ratio strength of 1x, set up the proportion 0.5 g/100 milliliters equals 1 g/x ml, then cross-multiply to get 0.5x equals 100, and solve for x by dividing 100 by 0.5, which gives you 200. Therefore, the ratio strength is 1 to 200. A quick tip is to remember that percentage is always parts per 100. Question 22. A water sample contains 1 part per million, ppm, of fluoride. How is this concentration expressed as a percentage? A. 0.1%. B. 0.01%. C. 0.001%. D. 0.0001%. Answer: D. 0.0001%. This question tests the conversion between different expressions of concentration, specifically from parts per million, ppm, to a percentage. ppm means parts per 1 million, while percentage means parts per 100. To convert 1 ppm to a percentage, you can set it up as a fraction, 1/1 million, and then multiply by 100 to get the percentage value, which equals 0.0001%. A simple way to remember the conversion is that moving from ppm to percent requires moving the decimal point 4 places to the left, dividing by 10,000. Question 23. An 4 pump is set to deliver 100 milliliters per hour from a 1000 milliliters bag of 0.9% NaCl. For bags typically have a 10% overfill. How long will the bag actually last? A. 9 hours. B. 10 hours. C. 11 hours. D. 12 hours. Answer: C. 11 hours. This question tests a practical aspect of for administration, accounting for manufacturer overfill. The keyword overfill indicates that the bag contains more volume than stated on the label. First, calculate the actual volume in the bag by adding the overfill amount. 10% of 1000 milliliters is 100 milliliters, so the total volume is 1000 plus 100 is equal to 1100 ml. Then, divide this total volume by the infusion rate to determine how long it will last. 1100 milliliters/100 milliliters per hour equals 11 hours. Always remember to check for overfill information in for calculations, as it affects the actual infusion duration. Question 24. Using Freud's rule, Calculate the dose for a 12-month-old infant if the normal adult dose is 500 mg. Fried's rule, age in months/150, * adult dose. A. 40 mg. B. 25 mg. C. 50 mg. D. 100 mg. Answer: A. 40 mg. This question tests the application of an age-based pediatric dosing formula, Fried's rule, which is sometimes used for infants. The formula is provided, so the task is to correctly substitute the given values, the infant's age in months, 12, and the adult dose, 500 mg. Plug the numbers into the formula, 12/150, * 500 mg. This simplifies to 0.08 by 500 mg, which equals 40 mg. While modern dosing is primarily weight-based, knowing historical formulas like Fried's rule can be helpful for certification exams. Question 25. An insurance plan reimburses a pharmacy for a drug at AWP-15% plus a $3 dispensing fee. If the AWP for a medication is $120, what is the total reimbursement? A. $102. B. $105. C. $123. D. $138. Answer: B. $105. This question involves calculating pharmacy reimbursement, a key component of business mathematics. The calculation is done in two steps. First, determine the drug cost reimbursement, and second, add the dispensing fee. The drug cost is AWP-15%, so first find the discount amount, $120 * 0.15 equals $18, then subtract this from the AWP, 120 to $18 equals $102. Finally, add the flat dispensing fee to this amount, $102 plus $3 equals $105. Always perform the percentage calculation first before adding any flat fees.